In this video, I want to solve problem 8 from Precept 4. So here's what we have. We basically have an insurance agency and they follow this kind of procedure. So they compute the person's probability of survival according to some model. And if that probability is less than P, they just turn the person away. If that probability is greater or equal than P, then they sell them insurance for some amount. That's the premium. Now, if the person ends up surviving, that's the end of it. If the person does not survive, then we'll pay them the benefit. Okay. Now, our goal here is to write a function that takes in a model, performs the prediction, and then basically computes what the profit or loss is under kind of the procedures that are defined by P and premium and benefit. So let me first write this without the function, and then we'll put everything in a function. So I have Titanic loaded. So the first thing I'll do is I'll get my model. So it's going to be GLM, and I'm going to say survived. And we'll predict based on sex and age and class, like this. Say family equals binomial, and data equals Titanic. So that is my fit. So what I want to do now is I want to actually see how much I'm going to make or lose off of that. So the first thing I need to do is I need to make my predictions. So I'll put them in pred and I'll do predict. Fit, new data is Titanic still. So here note that we're using the training set for testing, so that is kind of iffy, but we started doing this precept before we learned about the train validation test split. So for now, we'll just do it on the training set with the knowledge that actually we'll be over optimistic about how well we'll do in terms of predicting survival. So new data Titanic, and we'll say type equals response, so that the predictions are probabilities. Make sure it runs. Great. So now let's figure out how much money are we taking in. So we're taking in premium from each person who we take. How many people do we take? Well, as many as had a probability of survival greater or equal than P. How many is that? So we'll say prediction greater than P, and then we'll get a vector. Well, we'll need to set P to something, let's say 0.85. So prediction greater than P, that's going to be a bunch of trues and falses. Now, if we sum that up, what we'll get is just the number of trues, because falses contribute 0 to the sum and trues contribute 1. So how many people? 103. So each one of them is paying premium. So that would be this many times premium. So premium also needs to be defined. Let's say that the premium is $150 for now. So this is how much we're taking in. Now, how much are we losing? So in order to know that, what we need to do is we need to compute the number of people who we did not turn away, but who did not end up surviving. So how would that go? Well, this is all the people. Well, the trues correspond to all the people who we sold insurance to. So if there is a true, we sold insurance to this person. Now, the second part of it is that they have to not have survived. So if we say Titanic survived equals 0, well, here every true indicates did not survive. Now, if we combine them using the ampersand, we'll get true only for people for whom both the prediction was greater than P, and they did not survive. So let's look at what that looks like. So mostly falses, but you can see some trues sometimes somewhere. So here there is actually like a lot of trues. So okay, so how many people is that? Well, 3 people. Okay, so the trues that we saw were from some other kind of data. So okay, so how much do we pay them? So this is how many people, and each of them, their estate got the benefit. So This was the loss, and again, benefit, we need to define it while we're designing the function. Later on, of course, we get rid of that. So benefit, let's say, is $80,000. Like that. So let's see. So this is how much we paid out. This is how much we took in. So we can be nice about it and say that this would be the revenue, and this would be the expenditures. So like this. And now the total is going to be revenue, how much we took in, minus expenditure, how much we paid out. So in this case, the total would be minus $250,000 approximately. So let's now put all of that into a function. So we'll say total profit or something like that. And that's going to be a function. Now, what sort of information do we need here? We certainly need the fit in order to make the predictions. We need to know the P. We need to know the revenue. Sorry, not the revenue. We need to know the premium. And we need to know the benefit. So if we know that, we can just copy this. And we'll copy that. And we'll return the total. Okay, so I left fit outside the function. The reason is that what the function does is it takes in the model, and then it says, well, this is how much money you'll make if that is the model that you use. So conceivably you would try another model, and maybe that's going to work better for you. It does take in the P and the premium and the benefit. So in order to run it, we'll say total profit, fit, P, premium, benefit. So here, of course, I could just say 80,000 instead. So I just defined it here so that it's a little bit nicer. I made sure that the order here is the same. And again, be clear that I could also have said 0.85, or for that matter 0.80 here. That would be just as valid. So I'll just say P. And well, we know that I'm losing $250,000 here. I just need to define the function. So here I'm losing $250,000. So one possibility is we just fiddle with those numbers to see whether we can't improve our position here. Okay, so I increased the threshold to 90%, so I'm turning away everyone who is less than 90% likely to survive, and that is, I'm doing a little bit better. Maybe I should increase the premium, so maybe I'll sell the premium for like $1,200. Okay, that is better. Maybe 200, 2,000 rather. I'm almost breaking even, so one thing I could do is I could just say, well, I'll pay out 65,000. That seems like a pretty bad deal, but there you are. So that way I would be making $16,000. So one interesting thing is that if I try this, I'm actually losing money again. So it's not necessarily the case that if you increase the threshold P, you'll make more money. Sometimes you'll lose money, and that would be because you're turning away people who would pay the premium to you, but who would actually survive. So that is the setting that you might have found. And that's it for this problem.